Okay. So for this lesson here, tires and wheels, we're going to be focusing on, the wheels, which we often think of as rims, and the tire, which is the rubber part around the rim. Your associated review reading is chapter 36 in your CDX textbook there, that mobile heavy equipment book. Now we're just going to take a look at tires first of all here, and we'll take a little bit of a look at some wheels as well and have a discussion about that. Off-road tires, if you can see, there's construction, flotation, and traction. The difference between those, a lot of it has to do with the type of tread that's on there and the intended purpose. Okay. When we're looking at construction, those are designed to be very tough, very long wearing tires. They may not be quite as good in really bad off-road conditions as something like a traction tire that you'd find on a piece of ag equipment. But definitely better than a flotation tire. And a flotation tire is designed to give you, yes, a lot of flotation, but also to distribute the load or the weight of the vehicle over larger surface areas. So if you are on, let's say something like turf that you don't want to tear up, it doesn't have these big deep lugs that are going to dig in and start cutting up the turf. It's also going to help you to distribute the weight so that the tendency to sink in soft ground is going to be less as well. When we're looking at these different types of treads, one of them is clearly a directional tread. Which one?
Yeah, traction and the construction.
The traction and the construction. And the traction, well, both of them, but particularly the traction, you can see that V-shaped pattern there. Now, the reason we have a V-shaped pattern like that is, the lugs do give us really good traction because it'll bite into the ground and it'll transfer the driving torque of the machine to the ground so that we can drive, with heavy loads. But the V-shaped pattern of the tread is designed that way for a very specific reason. Why is that V-shaped pattern important? What does it do?
Because it'll clear the treads of mud and stuff, the way it flows.
Exactly. As if there's any wheel slip, it tends to push the dirt away and out of the tread, because as soon as you pack those treads with mud, for instance, it just becomes one giant slick. And if anybody, and I'm sure that it's happened to all of us, if you ever get stuck somewhere, as soon as you start spinning your tires, if your tread's all packed, that's it. It's one giant slick and you're not going anywhere. So then you got two choices. If you're just, in your, whether it's, a vehicle, or maybe you got like a quad or something like that, or maybe it is a tractor and you got it stuck in the mud. If your treads do start to pack up, then either spin them faster to help them clear, which means two things are probably happening. You're just digging yourself a deeper hole to try to get out of. Okay. Or go even slower and just hope it bites, right? But the whole idea of having that directional tread there is so that it's going to tend to want to eject whatever is stuck in the treads as that wheel slip occurs. So when you've got a tread that's a directional tread, how do we know that we've got those installed correctly?
There should be directional arrows on the sidewall.
I was going to say that.
Okay, so generally there is an arrow that'll tell you the normal direction of tire rotation. But if there isn't, then all you have to do is take a look at the tire and make sure that when you're looking at it, the tread bars are pointing down at the front. Okay, because when they're pointing down at the front, when you're driving forward, that's going to have the tread bars pointing in the right direction to eject the dirt as slip occurs. If you have them the other way, it's actually going to try and shovel dirt in underneath the tire, which isn't helping anything. Okay. Sometimes traction tires, you will see them mounted backwards if it's in a steering application. That'll be the only time. Another direction another example of directional treads would be, let's say, some automotive tires that have that V-bar tread on them as well. Those are generally designed so that they're going to help to eject water instead of dirt and mud. We're trying to get water up from underneath so we don't have hydroplaning happen. And it's just as important on a set of tires like that that you have them installed with the correct direction of rotation as well. Okay. And that means that when you're rotating tires in an automotive application with directional treads, you can only rotate front to back on the same side. Does that make sense? Okay. You can't go in an X pattern on those, because if you did that, they'd all be backwards. Aside from the forklift in your shop, solid rubber tires, any other examples you guys have?
Bobcats.
Okay, so yeah, skid steers will sometimes have these. Sometimes they got pneumatics, sometimes they got solid rubbers. Okay, it just depends
Sometimes
on-
if you rent those cheaper man lifts, they have those solid rubber tires on them.
Okay, okay. And a solid rubber tire, it's nice because there's nothing there to worry about in terms of, you know, puncture damage and deflation and stuff. So a solid rubber tire is good, but it's also kind of not good. Okay, it's really good if you don't want a lot of compression and stuff like that. You know, forklift, great example. You want to have a nice, stable, firm plant on the ground, right? But if you had, let's see, air-filled tires on a forklift, which sometimes you do, if you end up with one tire that's deflated, or, you know, one tire that's overinflated or something, basically you have one side that's a little bit squishier than the other, and then you lift a load up, and what happens? It's going to
Uneven.
start, yeah, it's going to start keeling over to the side that's underinflated, right? So you may end up with some side roll. So when you've got something like a wheel loader, you've got something like a forklift that has, you know, an off-road forklift that has pneumatic tires on it, tire inflation is really important, not just to make sure the tires are flat, but also to make sure they're even so that we don't have that side roll when you got a load on them. Okay. And another thing that pneumatic versus solid tires, pneumatic tires do give you a little bit of suspension too, don't they? So that there is a little bit of squish there that's going to help to absorb some of the shocks of driving around. You know, solid rubber tire equipment generally isn't designed for use in off-road applications. It's not to say that some people don't try, but they don't really excel at that. Anybody ever changed a forklift tire?
Yeah.
Yeah. It's a bit of a different process, isn't it?
Yeah.
You need a big press. You need a big press, because a solid rubber tire is literally a steel ring with this rubber vulcanized onto it. There's nothing to, like, yes, you can unbolt the rim, but the rim and the tire actually presses onto the rim.
This is onto the rim, yeah.
Yeah. So usually what you'll do is you'll take the new one and the old one, you'll set them up in a press, and you'll use the new one to press the old one off while you're busy pressing the new one on.
That's
And
how I did it.
Yeah. Okay. And when you did that, I don't know how big a press you had, but it gets pretty nerve-wracking until it finally cracks. And once it
Yeah, I
does
was
crack,
shitting my pants. I was like, holy fuck, man. Like, I didn't think our press was gonna be big enough. But it shrinks, like once you get it off, how much it shrinks, it's like I don't know how to describe it, but it's crazy how it just stays on there.
it is nuts. Yeah. I have not changed very many forklift tires, but I know that when we did it, I think it was at least a 100-ton press that I was using, and that
Yeah,
thing was grunting.
Oh yeah.
When she finally let go, it was one of the biggest bangs I'd heard in a while.
Yeah.
And then it finally started going. Right?
Yeah, once you break it, it's usually pretty good. But
Yeah.
pretty scary if it doesn't.
Oh yeah. Oh yeah. The pneumatic tire construction, I'm going to assume that most of you have heard the terms bias and radial ply before. But when we're talking about pneumatic tire construction, it's going to be one of those two types. If it's bias ply, it's probably a heavy duty off-road tire nowadays. We used to have bias ply automotive tires, but we don't do that much anymore. If it's radial, it might be an off-road tire or it might be an on-road tire. Most on-road tires nowadays are radial, not bias ply. Okay. Now, what does that actually mean? Well, it has to do with the way the tread plies are put together inside the tire carcass. Okay, so you got your tread plies, you got your sidewall plies, and we're going to take a look at this one first. And I do have some better pictures coming up that give a more clear distinction between the two. But what I do want to point out on this one is the way that all of the ply strands are oriented. And you can see that the way that they're oriented here, they're just crisscrossing back and forth across the tire. This, any idea what this one will be? This bias or would this be a radial?
I'm gonna guess
Bias.
bias.
Say bias play.
This one's bias, yeah. So the body plies, the tread plies and everything, they're all kind of laid across like this. And all of these plies, it's just cords running back and forth. And they do wrap around this bead ring here, okay? So this bead is usually several steel cables. And then all of those sidewall / tread plies, they wrap around there, and that's what forms a tire carcass. A bias ply tire tends to be a stiffer tire than a radial. It tends to hold its shape more even under heavy load, which can be a good thing. A tire that holds its shape better under heavy load. Go ahead.
If you have a set of those in a half ton, you can almost drive with no air in them, and you can't even tell.
Well, that must be a pretty old half ton then. I don't know where you find bias ply tires for a normal half ton nowadays. But yeah, I know what you mean.
Well, like the old 70s Ford trucks.
Yeah.
If you can almost have nothing in there, and it just looks a little bulged out. That's about it.
Yeah, exactly. The tire, like it doesn't tend to squat very much when there's load on it. And even when there isn't load, it's just a stiff carcass. It holds its shape very well. And what you're talking about there, even for an automotive application, back in the good old days before we had things like power steering as standard on every vehicle, having a bias ply tire actually made it a heck of a lot easier to steer the vehicle because the tire holds its shape. It doesn't squat down, and then your steering tires have less contact on the ground. So you're not trying to scrub as much rubber back and forth across the ground as you're steering the vehicle. With power steering, it doesn't really matter as much anymore. So radial tires, but that right there, I think I even brought up something else that's an issue with bias ply that's better with radials, and that's the contact patch on the ground. Because of how a tire sits on the ground, a larger contact patch is going to give you more traction. It's going to distribute the weight of the vehicle a little bit better. With a bias ply tire, you've only ever got, whatever part of the tire is touching the ground, hitting the ground. And if there's any side load on the vehicle, the whole tire just tends to roll like this. It doesn't just kind of squish side to side like a radial would. So your tire contact patch is less when there's side load. Okay. So there's places that would actually be good, and there's places where it's not so good. So here we've got a couple of different examples of tires. The bias, like we just talked about. We've got a bias belted, which really, if you're looking at this, a belted tire, what we're talking about is the fact that we have some tread belts, okay? Or tread plies, you could call them, because you've got sidewall plies, and those are the ones that wrap up around and go around to the other side like so. Okay, and then if you had tread plies instead of just simply sidewall plies, the tread plies are basically going with the tread. All right. If you take a look at the bias, you still have a bias carcass with some tread plies. It helps to hold the tires shape a little bit better under load. But then you have a radial, and this is the most common type of tire nowadays because it has a lot of benefits. So with a radial tire, you can see that your sidewall plies, or your body plies, they're calling them here, they do exactly what I just drew over there. They wrap around, but they wrap around parallel to the tire like this, right? So they're just wrapping around and just back and forth, back and forth. That would help hold the shape of the tire, but it doesn't keep it from just turning into a big balloon, right? So to keep the tire from just turning into a big balloon, that's where these, we're calling them stabilizer belts, but those are your tread plies, right? They go that way, and your tread plies help to hold that circular flat tread that we're all familiar with. Okay. So the tire itself is comprised of the beads. Okay, those bead cords are usually steel cords. The sidewall plies and the tread plies may either be some sort of nylon or Kevlar or steel. It really depends on the tire that you bought. Okay. And all of those work together because they're sandwiched into the rubber carcass of the tire. And the rubber carcass of the tire is generally made out of natural rubber, and it's vulcanized. And so we take natural rubber, we mix it with a variety of different chemicals, and then we go ahead and we apply all of the plies to it. And then we put another coating of rubber around the outside, and then we vulcanize it. What does vulcanizing mean? It's
Is
basically
that just
cooking.
a type of coating to
It's
it,
actually, it's not the type of coating, it's the process they use to turn the rubber from like sticky natural rubber into the rubber that we're familiar with for tires. It's where they cook them. There's no better way to say it than that. They actually cook the tires. Vulcanizing is taking the tires and subjecting them to high temperature and high pressure, and it changes the chemical structure of the rubber and turns it into that tough hardwired rubber that we know today. Depending on exactly which chemicals we use and exactly how long we vulcanize it for, we can make a really hard rubber compound, or we can make a softer rubber compound. Things like all-season tires or winter tires, for instance, right? So a softer rubber compound is better in the winter, but it doesn't last as long because it's not as wear resistant. So when it comes to actual tire construction, there's a fair bit going on there. Okay. So radial tires. Yeah, it's all pretty straightforward. One of the reasons why we can say that radial tires might have increased life is because of the way they're constructed. It tends to keep the entire tread of the tire in contact with the ground, and it does a better job of keeping it in contact all the time, whether we're just traveling straight forward or whether we got side loads because we're cornering. A radial tire tends to have a nice flat contact patch, which is good because if all of the tread is in contact with the ground, we're not going to have just certain areas of the tire wearing out. With a bias ply tire, it's very stiff, and it also tends to just roll instead of deflect to the side. Okay, and what that means is any cornering is going to start wearing on one side of the tire more. You're going to have less of a tendency for the entire contact patch of the tread to be in contact. Radial tires. Yeah, I think we'll use this. Yeah, we'll use this one here. So when we're looking at a radial tire, because of the way that the sidewall plies are laid, what that tends to do is it tends to allow the sidewall to bulge more when there's weight on the tire, right? And that means that the tire itself is going to give you a lot more cushion. So it's going to absorb more of the road shock. Another thing, because the tire sidewall plies are laid like this, the tire tread can deflect side to side. And all that does is instead of your sidewall plies looking like this, they're going to roll over a little bit and they're going to kind of flatten out on the other side. And that lets, again, the tread stay in contact with the ground, even though things are kind of swaying side to side on it. This is a good example of what I'm talking about in this picture here. And you can see the deflection from where the rim would be versus where the tread is hitting the ground on this one. Okay. When we have a radial tire here, the actual tread bars that are touching the ground, the tread bars that are touching the ground, even when there's deflection, they don't come up off the ground. And that means that, yes, they're going to wear more evenly, but also we're going to have more traction because we've got more of the tread in contact with the ground. So the tire footprint here, what this picture is trying to show us is if you had that tire sitting on a pane of glass with the weight of the vehicle resting on it, and went and looked up underneath it, what would it look like? How much of the actual rubber is touching the road, so to speak? And like I've been saying, with Radial, because of the way it's built, you end up with more of the actual treads touching the ground versus a bias. Because it's able to squat, it's able to flatten out that tread on the ground, and it gives us a better contact. Our bias ply, it's a good stiff tire, and it doesn't have very much sidewall deflection, which might be desirable given, you know, a certain application. Maybe a machine where you do want to have a nice stiff tire, you don't want it to roll very much. Yeah, maybe something like you know, a wheel loader or something like that. Not to say that wheel loaders don't have radial tires, because a lot of them do nowadays anyways. But here you can see that side deflection that I was talking about. It doesn't really happen here. And if there's side loading because of vehicles cornering, that tends to make the whole tire want to rock up off the ground, reducing your contact and reducing the traction. Not a great thing. When we're talking about the load range of a tire, that's typically established by giving a tire a ply rating. And a ply rating is really just talking about, technically, there should be physically 2, 4, 6, and so forth sidewall plies in the tire. The more plies you have, the stronger the tire is going to be, right? So when you're out buying a tire for, let's say, maybe you got a half ton or something like that, and you want to put some tires on it, and you're thinking, well, you know what, I can get different types of tires. I can get, you know, C-rated ones, or I can get B-rated ones. Which ones are better? Well, the more sidewall plies you have, the more load carrying capacity the tire has, because it's physically a stronger tire. And then if you took a look at other ones, like just on a car or something like that, or even on a lot of half tons from the factory that come with P-rated tires, what does that mean?
Shitty.
Yeah, it's like garbage.
It means they're not the best. I agree. A P-rated tire is a passenger-rated tire. It's not designed, you know, with a load carrying sidewall ply. So that is in and of itself going to limit the payload capacity of that vehicle. But keep in mind, guys, if you say, well, you know what, my half ton, it's got 1,000, maybe a 1,200 pound payloads, that's what I could put in the bed, or that's what I could haul in terms of, you know, hitch weight or something. But it's got P-rated tires on it. So if I want to bump up the load carrying capacity, all I got to do is throw a heavier set of tires on, and then it'll haul more weight. Well, that doesn't change the way the axle is built, does it?
No.
And that's the problem. What's the other trade-off there? And I'm talking specifically, like, you know, your own personal vehicle here, or maybe, you know, some of the half tons or 3/4 tons of the shop. What's the trade-off between running P-rated tires and running stiffer, you know, C or E-rated tires?
Right.
Your ride quality takes a big hit.
Pretty stiff.
Because the stiffer the sidewall, the less shock absorption you're going to get from your tires.
And your front end takes a hit too.
All of that banging around there is going to end up putting a lot more wear and tear on your front end components. Good point. Absolutely. Okay.
But it looks cool, so I mean, I'm willing to trade up.
You know, if you're going to throw a set of Duratracks on your truck there, I think that most of those, they'll even give you those in a P-rated if you really want. And I've seen some shaking. Yeah, no Duratracks. What do you need? Need your Bridgestones?
Got some Hercules.
Hercules. Okay, there you go. And I've run cheap stock tires. Those when you buy a truck nowadays, it seems like most of them come with those Goodyear SRAs. They're just junk. They don't last long. They don't have great traction. Duratracks, I kind of like. Do they last as long as some of the other ones? I don't know. I don't drive like I'm 18 anymore. I'll tell you that, guys. So my tires do tend to last a little bit longer. But yeah, I do know that if you go with some of the heavier, you know, higher load rated tires, a little bit stiffer sidewall, maybe it does help to improve the tread life, because you got less of the squat and less of, you know, the tire deforming itself. But the trade-off there is your ride quality and possibly the life of some of your suspension components. Ply rating is important though. Go ahead.
My big thing's the gravel. When you put like not high rated tires on, you get little pebbles that start to poke through if you do a lot of gravel driving.
Yeah, I don't do very much gravel driving these days, but when I was younger, I grew up in Interlake and drove a lot of gravel, and it didn't matter what you put on. Tires just didn't last that long, you know. If there's a star rating, again, this is more of a passenger car thing, but if there is a star rating, it is related to the maximum manufacturer's recommended pressure for the tire. Okay. If I'm trying to figure out how much pressure to put in the tire, though, there's two things I'm going to look at, and it's probably not going to be the star rating. I'm going to be honest with you. There's two things I'm going to look at. One of them is the maximum pressure rating on the tire itself, and the other one is another pressure rating. Where do I find that?
On your door.
The door jam or the operator's mat or owner's manual.
Mhm. And it's not that unusual to find out that the recommended tire inflation for the vehicle is less than the maximum inflation rating of the tire itself. Okay. So when you're looking at those two things, tire inflation, the amount that you inflate a tire, is to a large degree dictated by the amount of load that that tire is going to be carrying. You know, up to obviously its maximum rating, right? So if you've got a tire and from back in my day, 35 psi for a car tire is kind of what it always was, right? But nowadays with the low profiles, we run higher pressures. So if it says 41 psi on your door, but it says 55 psi on the tire, if you inflate the tire to 55 psi, you're going to start to deform it a little bit, because the weight of the vehicle only needs 41 psi for the tire to sit properly. Does that make sense? So if I overinflate the tire and it starts to kind of balloon the tire a little bit, then I start wearing out the tread just in the center strip of the tire. You know, now if my tires are underinflated consistently, then what will end up happening is the tire wants to kind of collapse on itself a bit, and it's going to start wearing out the outer two edges of the tire. So proper inflation is important. And I know there's some people who just look at the number on the side of the tire, fill it up to that, and call it good. And you're probably going to get away with that. The problem is, if you didn't need it that inflated, you end up with less traction. You end up with increased tire wear, and you shorten your overall life of the tire and possibly the safety as well. Yeah. We talked about directional treads already. And here we have all kinds of information that is available on a tire. This is all just molded right into the rubber. You'll be able to see this when you walk up to a tire and have a look at it. And this is actually one of the things that I want you to do today. This is going to be our very first activity in the shop. In your workbook, we have some workbooks for you guys. Okay, in your workbook, there is a section I'm going to have you go through. And it's going to be basically pick a tire, any tire on a machine or a vehicle, I don't care what, get all of this information off of it. And then what we're going to do is we're just going to use what we know and a little bit of information available on the internet to figure out as much as we possibly can about that tire. All right, so let's talk a little bit about what some of this means. So first off, we've got the number that we look at when we're trying to figure out what size of tire we need if we're going to replace our tires. Okay. So when you look at the tires, just because you've got a certain brand or style of tire on your vehicle doesn't mean that that number is going to change. Like, you can have some nice aggressive, off-road tires. You could have some pretty tame, passenger type tires. You could have whatever you want. But the one thing that should stay the same is the size of the tire. All right. Now, if you start putting oversized tires on a rim, then you run into issues where when you turn that tire in the wheel well, it's going to start rubbing stuff inside of there. If you bottom out your suspension, it might start rubbing on your fenders. And that's where guys get into, spacers and lifts and trimming their fender flares, or, all that kind of stuff. You start trimming stuff off. If you'd stay with the right size tire, you wouldn't have those problems. Okay. So most automotive style and some of the heavy duty style tires are going to follow this numbering logic here. So first off, we have a letter. Okay, so that letter is a P. And that just simply means it's a passenger tire. There's different letters that might be on there, something like ST or an LT. You know, things like that are giving us the tire designation in terms of what its intended use is. And we'll go through those in a minute, okay? Most of the tire sizing numbers here have to do with the physical size of the tire. And it's a very interesting combination of metric and standard, okay? But the nominal width of the tire in millimeters is the first number, 215. And what that means is if you're looking at this, the tire itself, the tread would be roughly 215 millimeters wide. Okay, it's the nominal width of the tire. If you take a look at the next set of numbers, that is called the aspect ratio. Okay, so what exactly is the aspect ratio? What does that mean? Well, what it really means is that the tire sidewall height is 65% of the tire tread width. We call it an aspect ratio, but that's really what it means. So that means if I wanted to figure out how tall this tire, the actual sidewall of the tire was, it would be 215 divided by 65, or, well, let's do this a little bit nicer. Because I said, there we go. Okay, so that's going to give us a number, and I don't know if it was off the top of my head. So let's go to 15 times 0.65. That means that this would be 139.75 millimeters. Okay, now what does that tell us? That tells us that the aspect ratio number, the lower it is, the lower the profile of your sidewall is going to be. And if you think about it, isn't that true? Like if you're running, you know, 50s or 45s or something, those real skinny tires that you have on some of the smaller vehicles, maybe they got great big rims, but there's just a little teeny weeny skiff of rubber on them, and that's about it. Okay. Or if you take a big beefy truck tire, that sidewall number might be 65 or 75 or even 85, right? So you got a nice big tall rubber portion on your tire. Why do small high performance cars tend to favor really skinny tires? I shouldn't say skinny, small sidewalls is what I should say. Why do they tend to favor small sidewalls, and bigger trucks, you know, off-road trucks tend to have thicker sidewalls?
Because when you're about to gap a Chevy Camaro or something, you don't want all that flex when you first take off. If you ever watch the thick tire, it flexes a lot or conforms to what's going on around it.
Yeah, you look at some of those drag slicks, you look at the way those things wrinkle up when they're first launching, it's crazy.
That's what I was thinking about there.
Yeah, yeah. But you know, the bigger part of it is if you're looking for a vehicle that sticks to the road like it's on rails, you don't want a lot of sidewall deflection. And guess what? How you get rid of sidewall deflection? Don't have sidewall, right? That's kind of what it boils down to. So if there's very little sidewall, there's very little deflection, and that means when you're going around corners and pretending that you're in the Fast and the Furious and drifting your car around all over the place, well, it's going to stick good until it doesn't stick, and then you're going to be able to drift like just totally awesome, right? Anyways, if you get a truck that you want to take off road, little teeny weeny sidewalls don't give you any squish, right? And you go ahead and you take that through some rough terrain, you're going to be beating the heck out of your rims because the tire doesn't have enough give to absorb that. And if the tire's already collapsed in one spot because you're going over a rock, there goes your rim. The one thing I will say though, if your vehicle is a pavement princess, and it doesn't matter if it's a 3/4 ton diesel or if it's a Honda Civic that's completely done up, if it's just a pavement princess, your sidewall height, actually having it as low as possible is good in terms of fuel economy.
Oh yeah.
Because all of that squish on the side of your tires there, it takes energy to do that. And that energy, it comes out of your gas tank. So if you put a big fat set of tires on your 1/2 ton or your 3/4 ton or whatever it is you got, you're probably going to notice your fuel mileage takes a big nosedive, doesn't it? It's all worth it for the loss of enterprise. The next thing that we have here is a speed rating and a load index. Okay, these numbers here, I'm not going to tell you specifically what any of them mean. I'm going to have you guys look those up yourself. But what I will say is that the speed rating of a tire, the letter, is really indicative of how that tire is going to handle high speeds. Because something does happen to tires. The faster they go, the more centrifugal force is applied to the carcass of the tire itself. And what happens to a tire if you're going way too fast? What can happen?
Fall apart.
It can fly apart. All that centrifugal force can cause the tire to start delaminating internally, and then it just blows up. So you're going to want to make sure that if you are using your tires for high-speed driving, which, you know, track use only, right? Make sure that that letter is as high as possible. The load range is the number, and that is going to be related to the amount of load carrying capacity for that tire. The higher the load range rating number, the higher the load carrying capacity of the tire is going to be. Okay, but I'm not going to tell you how many pounds a 95H tire is rated for and how fast it's rated to go. You can go check those specs yourself. Okay? You will also have a maximum load rating number on the tire. Your maximum load rating number is always in the same spot, or like tied right to the same spot as the pressure. So it tells you what the maximum load at the maximum pressure is. One way you can get the payload rating of a vehicle up is to increase the tires, like increase the load rating of the tires themselves, put a better tire on. The load rating of the tire is directly related to the ply rating of the tire. All right, so better ply rating means better load rating, which means more load carrying capacity. And the other thing is, if you put more tires on, you can carry more load. Why do you think we have dualies? Okay, and why do you think all semi-trucks are run? Well, I shouldn't say all semi-trucks because some of them are running super singles, but you know, for the most part, we run duals. It increases the load carrying capacity. That's why. There's a couple of other things that you would find on a tire. It'll tell you whether it's tubeless or not. It'll have a DOT rating, okay? And the DOT rating is something that you would need to have on a tire if you want a vehicle to pass a safety. If you put a set of off-road tires, let's say, you know, you've decided that driving a side-by-side or driving a quad is not the thing for you anymore. So you go get one of those little Suzuki mini trucks. I think you guys over at Alternative, do you guys got some of those, Chandler? I think you guys do. But anyways, some guys will go buy those. You got them?
What's that? Sorry.
Those little mini trucks?
Like the Isuzu ones?
No, I was thinking like those little Suzuki, those little mini ones. Is that you guys or is
No, that's the water company.
Livingstone? No.
No, Livingstone doesn't have those. It's those guys that have the fucking the water guys on Richmond. They do the sprinklers, the underground sprinklers.
Oh, okay, okay.
They've got one of those little. Yeah, they've got one. So does I want to say Denray Tire or something.
Really?
Maybe, I don't know. We've got an Isuzu. It's weird as fuck.
Okay. Well, some of those little mini trucks, the guys will buy those, and you know, if you get them safety and everything, you can drive them on the road if you want, but you can also bolt on, you know, a set of Outlaws or something on them and go off-roading. The problem is those Outlaws are not DOT rated, even though you can do like 100, 140 kilometers an hour in a side-by-side on them, and they seem to handle that just fine, right? But you put them on a little Suzuki and all of a sudden it's not legal anymore because it's missing this DOT rating. Okay. The other thing that you should be able to find on a tire is going to be an indication of when it was made.
It's D&B sprinklers. That's who it is.
It's D&B? Oh, okay.
Yeah, they've got
Okay.
one of those little things.
I've seen a few of them running around town here. I thought
Yeah.
you guys had one.
No, ours is just that Isuzu. It's just a cab over. It's
Okay.
got a deck on it and everything.
Yeah, yeah. No, I'm talking about those little baby ones. They're smaller than that Isuzu you guys have, though.
Yeah.
Yeah. Part of the DOT number, guys, is going to be a date code. All right. So I'm not going to tell you exactly which number it is. That's one of those things I want you guys to figure out yourself. So what we're going to do is we're going to get all the numbers, and then you're going to maybe just start Googling tire identification information. And it's gonna help you identify what part of that number is the date code that tells you when the tire was made. Why would you care about that? Well, let's say that you've got a piece of equipment that's sitting out in the back 40, and it gets called into service again. Okay, and that piece of equipment, maybe it's a trailer, maybe it's a truck, something like that, and it hasn't really traveled very many miles, but it has been sitting out there in the sun for the last 5-10 years, and you got to wheel it in, you got to get a fresh safety on it and get it back out on the road. Look at the tires, tire tread depth is good. Look for cracking and stuff like that. You don't see any cracking up there. Looks pretty solid. We can put a safety on this. And then, 3 days later, you get a call saying, yeah, that truck you just safety blew a tire. What are you talking about? Those tires get old, they dry rot, and then they're just not as strong. Okay. So checking the date code can help you figure out how old a tire is. That's the point I'm making. So as you can see, there is a lot of information on a tire. And being able to look at it, there's more to know on the side of a tire than what the PSI is supposed to be and what size it is. There's more going on there. So here we have LT, C, ST, and T. Your LT and your P rated, P for passenger. Those would be the two common ones in automotive stuff. Commercial tires, semi-truck tires. ST special trailer, those are usually like your little China bomb tires you go buy at Princess Auto to put on your camper or your sled trailer, right? Those ones, they do have a reasonable load rating capacity until they don't because they blew up. T, those are your little temporary tires, and those are like your donuts, right? So a donut tire, a spare tire, those ones are usually a very, very basic tire, generally rated for fairly low speeds. And when you put those on, they're designed to carry the weight of the vehicle from wherever you are to wherever the tire shop is. They're not to drive around for 3 weeks until you save up enough money for a new tire. You're supposed to just...
Those are performance at a Grand Am in high school. I had 3 donuts on at one time.
Jeez.
Fuck, it used to skid hard when you'd lock up the e-brake.
That is scary.
Well, that
That
thing was
is
wicked.
scary. Okay, what else we got? Okay, so 95. Oh, the R15. Sorry, I forgot to talk to you guys about that. I think we all know what that means, all right? That's the rim diameter in inches. Okay. 65 is the aspect ratio. R stands for radial. 15 load index rating. Okay, and like I said, your load index rating, it's not that it's like 950 pounds or something like that. The load index rating is related to an actual load carrying capacity. Okay. The speed rating is going to tell you what the maximum safe speed to operate that tire is. The higher the letter, the higher the safe operating speed. Okay. We'll talk a little bit more about tire sizing here, and then we're going to wrap this up fairly soon. But there is another way of rating tires, and that would be just like basically a tread width and rim diameter. Some tires are rated like that. So, if you've got, in this example here, 24.5-32, this would be like a heavy equipment or an ag equipment type rating that you might see. Some of them have metric ratings, but some of them are just like this. And that just means the tire is 24.5 inches wide on a 32-inch rim. Okay. And with a tire like this, there is going to be more information available, and it is going to tell you a little bit more about the tire. It's not just this. You're still going to have those other markings on the tire that give you things like safe working pressure, load rating, maximum weight, and so forth. So when we're talking about tire inflation, there's kind of two parts to this conversation. One part is the safety aspect of it, and the other one is the tire tread life. So let's start with the safety aspect, okay? When we inflate tires, we basically just check the pressure, and if it's not full enough, we put more air in, right? And you should do that when it's cold, because when a tire warms up, the air tends to expand and the pressure is going to go up. So you should be checking your tire pressure is cold. If you're inflating a tire, you should be aware of the fact that a tire can come off of the rim while you're inflating it, particularly if you overinflate it, right? You've probably seen those videos of tires blowing up. Has it ever happened at any of your shops? Okay, so Mark, you're saying yeah?
Yep.
Oh yeah, I always hear the truck shop make a big bang.
Yeah, and you know what? When a tire goes, that is a lot of potential energy that gets released. Okay, and think about it: where and how is it going to come off that rim? If it's going to, it's going to come off the rim, and it's basically going to blow the tire towards you if you're sitting right in front of that tire with your chuck filling it up. So, are you guys at work all in the habit of using a clip-on tire chuck with a whip hose, and then one of those tire inflators that you stand to the side of the tire?
Yeah, just use a digital gauge.
Okay.
My
So if
hand inflator.
Oh yeah, yeah. So if
Some
you
of those
have
loaders, some of those loader tires are so fucking big. If it blew up, you'd be done. I hate standing near them.
and you know what, I know that if it's going to go, if I'm standing in front of it, I've got a 0% chance if that lock ring lets go. If I'm standing to the side, I've got a lot better chance. Yeah, I'm probably going to get hurt, but I'm not going to be dead, right? So inflating in a cage, best case scenario, but you can't exactly put a tire in a cage if it's still on the machine, right? So if I'm going to inflate a tire, I know that there was lots and lots and lots of times that I sat there with one of those little teeny weeny chucks on the end of an air hose and held it on the tire, sitting in the rim while I did that. Okay, things have changed since those days, though, guys. Now you've got proper clip-on tire chucks with, like a 4-foot whip or something, and just an inflator valve, and you can inflate a tire and stand to the side, which is the safest place to be while you're doing that. So I'm hoping that you guys are using those, and if you're not doing that, maybe consider doing it. Now, one place I know is a real pain in the butt to do that is if you're doing, say, inner duals on a semi. Sometimes those, it can be tough to get in on that inner dual and have a chuck stay on there while you're trying to stand to the side to fill. I totally get it, guys, but be as safe as you can be. Okay? Now, under and overinflation in terms of you physically doing it versus how safe it is on the road. Overinflated tires give you less traction, can be way less safe. Underinflated tires will actually give you more traction. Anybody who's been off-road knows that. You always air down your tires, get you more traction, but it's going to reduce your tread wear. And the other very dangerous thing about underinflated tires in a continuous on-road application is all of that extra flex on the sidewalls. What does that do to your sidewalls? Heats them up, flexes them,
Destroys the core.
starts to destroy the sidewall plies. And now you got a tire that can have a sidewall blowout if you're running too long like that. Okay. So underinflation is very, very dangerous because of that. All right. If you're just airing your tires and your Jeep down, go off-road for a little while, and then bringing them back on the highway, that's not what I'm talking about. This continuous flexing at high speed, it heats up the sidewall and causes that degradation. So correct inflation, very important. If you've got tires that are liquid filled, and this is a thing that very big in ag, but not necessarily as much in heavy, definitely not in automotive. But if you got liquid filled tires, then the reason that we're putting the liquid in there, just hang on, guys.
That's just
Hole marks.
I'll get it back from you.
Yeah, I'll take a look at that after I'm done.
Sure.
Yeah, thanks. Sorry, guys. So anyways, if you've got liquid filled tires, the reason we do that is to get weight in the tires. And for those of you guys over on the farming side, I'm sure you're quite familiar with this. For those of you guys in the truck transport or heavy duty, you might not have ever seen a liquid filled tire. I say liquid.
Actually,
Pardon me?
Packers have the balance tires.
Okay, okay.
Funny, the first time you bring the new guy with a tire chuck, tell him to check the pressure, then calcium starts pouring out of the tire chuck.
Yeah. So if you don't want calcium to start pouring out of the tire chuck, seeing as how you brought it up, Aiden, go ahead and tell us what you should be doing when you're checking the pressures on a liquid filled tire.
You're actually supposed to rotate the tire till the valve's at the top. Like that.
Yeah.
If you're feeling lazy and don't want to get in the cab, then it takes a lot longer to fill a tire up, and you fill your chuck up with calcium and your hands get all sticky and it's just a big fuck around.
And your tire chuck and your pressure gauge, they don't last very long if you keep filling them up with calcium. Don't ask me how I know that. So when you get calcium filled tires, and you hear us say calcium, guys, for those of you not super familiar with this, the liquid ballast in the tire is a mixture of calcium chloride and water. It's literally salt water, okay, that we fill them with. And it's, I forget what the exact ratio is. It might say somewhere here in your book that's like an extra 8 or 12 pounds per gallon that it adds to just the water weight. It's an insanely high concentration of salt in that water. But we're just trying to make it heavy, get ballast weight on. So if you don't want that water coming out into your chuck, or when you're trying to check your pressures, then rotate the tire until the stem is at the top, because you're never supposed to liquid fill a tire above the top of the rim. And then this means you're actually checking and adjusting the air pressure, not checking, through all of the liquid calcium that's, or the calcium and water mixture that's in there. All right. So stems at the top if they're liquid filled. And if you have, just cast iron ballasts, weights or something like that, then it's a lot easier, because those ones, there's no water in the tire to worry about. Now, part of a pre-trip, and here I'm talking, semi trucks and things like that. Part of a pre-trip trip is checking your tire pressures. And checking your tire pressures by bouncing a mallet off them just tells you if they're totally flat or if there's at least some air in them, right? So when a truck is in for service to do an oil change once a month and you check the tire pressures, that's great. But they should actually be checked a lot more frequently than that, just in case you got a leak or something like that. Okay. And another thing with a tire that's underinflated, think about this. If your tire is underinflated and you're driving, and it happens to be one of a set of duals, as one tire deflates, it's less able to carry the load. So what happens? The other tire that's holding there still, it's carrying all of the load. And as it's carrying all of the load, that means it's starting to heat up and it's starting to degrade itself. We did talk a little bit about inflation safety already, but I think that what we'll do is we're going to cut the lesson off here. And we're going to pick it up and talk about inflation safety and a few more things to do with tires in the next lesson. And we're also going to get into some information on wheel alignment and steering geometry and that as well for our next lesson. Okay, but right now I think we're going to go ahead and pause this lesson.